So for this one here, they want us to find all of the roots, or in this case, the complex roots of this polynomial. It is of degree 3. And because 3 is odd, we're guaranteed at least one real root. So I'm okay, as we discussed in class, if you guys just use Desmos to find the roots that are real and that are rational. Or you could just go the rational zero theorem and find the factors of this and divide it by the factors of that, like we did in class. But for the sake of efficiency, I would highly recommend that you guys just go to Desmos to get a graph. And if we do go to Desmos, here's what Desmos would say about the graph of that function. And so taking a look here at Desmos, you can see that the curve has been typed in, and we can compress the y-axis to make it look a little nicer. And if we zoom in here, we see that positive 2 is a root. So this polynomial has a degree 3. It has 3 roots. One of them is real. And if I zoom out, you can see that there are no others. So one of them is real, and 2 of them are going to be non-real. So let's find the 2 that are missing by going synthetic division. So let's show the whiteboard, and let's go back to synthetic division, and we're going to use the root of 2. So if we go like this here, we can use our coefficients, 1, -8, 25, -26. Recall this process. And of course, the 1 came from the invisible coefficient of 1. And we're going to use 2 because 2 was a known root. And then recall the multiplication and addition algorithm. That's the remainder. This is our constant. And this might ring a bell. And then if I use a different color, we know that this is going to be x and that this is going to be x squared. So we have x squared minus 6x plus 13 is equal to 0. So it becomes a matter of solving this equation because this equation has 2 roots, the 2 roots that we're missing. And I think that the directions actually wanted only the complex roots, or like the non-real roots. So why don't we solve this equation here by perhaps going quadratic formula. So we can go quadratic formula with our values of a, b, and c, where of course 1 is the one in the front. So this would say that x is equal to the additive inverse of b plus or minus the square root of the square of b minus this product here. All of this sitting above 2a. And this would be 6 plus or minus the square root of. That'll be 36 minus 52 over 2. And if we get rid of this here, this will be 6 plus or minus the square root of -16 over 2. And this is 6 plus or minus, how about we go square root of -1 and then square root of 16. So that this gives 6 plus or minus 4i, right? 4i, and then divide everything by 2, 3 plus or minus 2i. So we reduce every coefficient by 2. And these are the 2 strictly complex roots, right? 3 plus 2i and 3 minus 2i. So again, I'm totally fine if you guys use Desmos to find the roots that are real and rational, and then go synthetic division to get some sort of a polynomial, which you can then probably solve with the quadratic formula, assuming that there are 2 roots left to find. So I hope that helped. And of course, please let me know if you have any questions.